In this lesson, we would like to explain about adding probabilities. The first objective of the lesson is to find the probability of mutually exclusive events. And the second objective of the lesson is to find the probability of inclusive events. In today's lesson, we will only be explaining the first objective of the lesson, which says find the probability of mutually exclusive events. The question is, what is mutually exclusive events? In very simple words, an event which cannot happen at the same time. For example, turning left and turning right at the same time are mutually exclusive because you cannot turn left and right at the same time. Another example of mutually exclusive event could be tossing a coin, because getting a head and a tail at the same time is not possible. Therefore, we say they are mutually exclusive. So mutually exclusive events implies that they cannot happen both at the same time. Next question is, how do we find the probability of mutually exclusive events? The answer to this question is given in the key concept. The key concept states, if two events A and B are mutually exclusive, then the probability that A or B occurs is the sum of their probabilities. In other words, probability of A or probability of B is equal to the probability of A plus the probability of B. Basically, we find the probability of each event and add them together to get the probability of mutually exclusive events. Before I explain example number 1, kindly note that this formula can be extended to any number of mutually exclusive events. So let's have a look at our first example of today's lesson. In this example, we would like to explain about two mutually exclusive events. The question says, Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 soccer cards. If she selects a card at random from the stack, what is the probability that it is a baseball or a soccer card? In this question, they would like to find the probability of a baseball or a soccer card. We say that these events are mutually exclusive events because the cards cannot be both a baseball card and a soccer card at the same time. Second point to note is that there are in total 19 cards. Using the mutually exclusive event formula, we say the probability of a baseball card or a soccer card is equal to the probability of baseball plus the probability of soccer. Since there are 8 baseball cards and 6 soccer cards, the probability of each of them would be 8 out of 19 and 6 out of 19 respectively. Adding both probabilities, we get 8 out of 19 plus 6 out of 19 equals to 14 out of 19. So the probability that Keisha selects a baseball or a soccer card is 14 out of 19. We would like to conclude the lesson at this point. I hope you understood the video and thank you for watching.